Okay, so this is a complex question on Le Chatelier's principle. And what we will do is we will see that we'll have equilibrium into vanadium 3 plus and bromide. I will write the equation and then talk to you about the questions that will be probably asked or you may see. So this is the equation that is given to you, and this is what is happening is that in a sealed flask, the equilibrium is reached, and this is the equilibrium expression or the reaction. Now, the very first thing that you may see is to write equilibrium constant expression. So write an expression. This will be the easiest question for this. Now, as we have mentioned even before, when we are dealing with the constant the equilibrium constant expression, what do we not exclude is the solids and the liquids, unless everything is in liquid. So water here is in a liquid state, which means that is excluded from the equilibrium expression. And the equilibrium expression deals with products over reactant, and the coefficients become the exponents. So in this case, the equilibrium expression will be something like concentration of vanadium oxide 2 plus in aqueous solution to the power of 2, because it has a coefficient of 2, times the concentration of hydrogen plus or proton to the power of 4, times the concentration of bromide ion to the power of 2 over the concentration of V3 plus to the power of 2 plus, or times bromine to the power of, or to the power of 1, because it is that with a coefficient of 1, and we exclude the water, since it is liquid stage. Now, one question may be asking what color change, so what color change would you expect if you add vanadium 3 nitrate into the solution? Okay, so what you are doing now is you are adding vanadium 3 nitrate. So when you are adding vanadium 3 nitrate in the solution, what you are doing is, since it is a solution, then will be dissolved into vanadium 3 plus and nitrate. Okay, therefore, what you are doing in terms of the Le Chatelier's principle, you are adding the concentration of vanadium in order to apply the Le Chatelier's principle. What it means is that this vanadium should be used up so that the shifting will happen toward the products, or will be shifted to the right, so that it is used up. Next question that you may see will be what effect would have if you add a catalyst when the equilibrium is reached. At the equilibrium. If you are adding a catalyst when the equilibrium is reached, nothing will happen because the catalyst either will speed up the reaction to reach the equilibrium, but as the equilibrium is reached, the catalyst doesn't have any effect on it. However, if you add a catalyst before the equilibrium, then the equilibrium will speed up. The equilibrium will speed up. So for this one here is nothing. And for this one here will be the equilibrium will, or the reaction will speed up to reach the equilibrium. The equilibrium is reached faster. Understand? But as the equilibrium is reached, then there is nothing that you can do on that situation. What effect will have, next one will be, what effect will have if the pressure, so pressure is increased. Now, what did we say in terms of the pressure is that if the pressure is increased, the volume, therefore volume is decreased, which means that in general, the equilibrium will shift toward the side with fewer molecules. But if we take a look at gases or aqueous molecule, but if we take a look here, the number of molecules is the same. So then will not have any effect, and it is aqueous solution, so will not have any effect into it. Now, what is very important to discuss and analyze, because this is easy part for you, I hope, is what effect will have adding silver nitrate. Okay, when you have silver nitrate, and silver, adding silver, a compound of silver is a very common and very, I would say tricky, but now that we will go over it, then I hope that will not be that tricky. It's very common that you will see as a higher mental activity question on the diploma or unit test. Now, as I mentioned, even in class, when we take a look at the table of solubility, silver creates precipitate with a lot of compounds. And on this case, we have to double check and see if the compound that is created between silver and the negative ion in the solution is able to create a precipitate. Because when we are adding silver nitrate in the solution, what we have actually is two ions, is a silver ion and nitrate, okay, in aqueous solution. So being present in the solution, silver ion will see if they can bond with other ions in the solution. And then when we see is the bromide ion present in the solution, and when we take a look at this table of solubility, we notice that silver bromide is creating a precipitate. Okay, so what it is saying here by creating the precipitate is saying that the bromide, let's use a different color. It's saying that bromide ions are used up. Okay, are used up. So based on the Le Chatelier's principle, what it is happening, the reaction will be shifted to replace the bromide ion that are removed. Okay, so even on this case, based on the Le Chatelier's principle, the reaction will shift to the right. Okay, now what effect will have if we add sodium bromide in the aqueous solution in the flask? So when we add sodium bromide into the solution, what we see is actually the two ions, because sodium bromide is dissociated into sodium and bromide. So what is happening in this case is you are adding bromide ions, okay? By adding bromide ions, what will happen based on the Chatelier is the opposite of what happened when we added silver nitrate. So the reaction will shift to the left because they want to use up what it is added. Okay? Make sense? Good. And now the last thing is what will happen if we add hydrochloric acid into it. When we add hydrochloric acid, what we are doing, actually, we are adding protons, or that is known as the hydronium. Okay, when we add hydrogen, protons, then what based on Le Chatelier, what will happen to reach the equilibrium is the equilibrium will be shifted to the left as well. Okay, because they want to use what it is added into it. Make sense? Now what we will do is we will see how can we graph those changes into how can we graph those changes that we expressed into Le Chatelier principle graph. So as the first change, what we will do is we will add V3 plus. Okay, by adding V3 plus, what you will notice is a rapid change, an immediate change on V3 plus, and then you will see that we'll reach the equilibrium. And as we said when we explained the Le Chatelier's principle graphing, it never reaches the original point. And as is it the reaching the equilibrium point, then we will see a decrease on the bromine, because they are on the same side of the reaction. So if you remember the reaction that we had, it was 2V3 plus in aqueous solution plus 2 water molecule in a liquid plus bromine gas, but aqueous solution, and then it is reaching the equilibrium to VO2 plus in aqueous solution plus 4 hydrogen plus and 2 Br minus in aqueous solution. Okay, so will be a slightly change. Now, since it is changing Since those two are going down, then VO2 plus will go up until it reaches the equilibrium, and bromide will go slightly up as well, and hydrogen proton will go up, but a bit more because it has a coefficient of 4. And this will be when it is reaching the equilibrium. And now at the second, what do we do? As it is reaching the equilibrium, we add a catalyst. And as we said, when the equilibrium is reached, the catalyst doesn't have any effect on it. So everything will stay as it is. Nothing will change. All of them, all the lines will be exactly the same. And the last is, okay. And the third change that we are introducing, the third stress, is odd pressure. And as we said, there is no change on it as well. So at 4, the equilibrium, the cost, of course, the equilibrium constant will be the same, but even no changes will be introduced to the coefficients or to the concentrations of the solution. And the last is green. Okay, so, and it is reaching the fourth one, and on the fourth one, what we are doing is we are adding silver nitrate. Okay, and as we said, when we add silver nitrate, the silver bromine is a solid, is a precipitate. So what do we notice like immediately is the bromide is used up, and then it is reaching the equilibrium. And if bromide is used up, what is happening is that hydrogen, it is increased a bit, and then vanadium, sorry, it's decreased. It's decreased. So it's decreased. One second. So this is decreased. So then it is shifted to the left. It is shifted. This is decreased, so it is shifted to the left. So if this is decreased, then it is shifted to the right to produce more. So then what we will have is we will have more of hydrogen. Yeah, we'll have more of hydrogen, more of VO2 plus. Okay, and then less of a bromide and less of V3 plus until the equilibrium is reached at 5, where we introduce it with different stress. And now what we had is we add sodium bromide, and as we said, when we add sodium bromide, then we have two ions, bromide. So what we are doing here is immediately we are adding bromide, okay, and then the equilibrium is reached, and as we are adding that, then the hydrogen will be used, and so will be VO2, and what will happen with bromide will be increased slightly, and Va3 plus will increase slightly as well, and this will be where the equilibrium is reached. And now we introduce it to a second last stress when we are adding hydrochloric acid. And by adding hydrochloric acid, what we have is we are increasing the concentration of hydrogen, and by doing so it is like a jump on hydrogen, and then the equilibrium is reached. And as a result of this, the bromide is used up, okay, and so it's blue now, so is VO2 plus is used up until the equilibrium is reached, and then we have increase on bromine gas or aqueous, and then an increase on vanadium 3 ion. And then if nothing is happening, then we'll stay in a dynamic equilibrium for as long as it is introduced to a new stress. So this will be pretty much what you will see on the Le Chatelier's graph, and we will do more of those questions in class.